Hello guys, so my name is Mohammed Izhaan, and I'm pursuing a bachelor's degree in civil and environmental engineering from IIT Patna. So we have got some questions on our hand for today. So the first question that you guys have asked me is to factorize x square plus 10x plus 24. So it is a basic question, right? Now we have factorized this whole function in two parts. So this was the question. And it is a simple question, no need to like explain anything in this. And now I'll be jumping on to the next question. So the next question that you guys have asked me is, what is a subset? What is a subset? Okay, so let me give you an example over here. See, I'll say that I have a bucket which is full of water. So this is a bucket. Okay. This is a bucket and it has many, let's say it has many fruits, different type of fruits. It has pineapple, it has guava, it has apple. Okay, so different types of foods are there. It is filled with. Now a person came and he brought a bowl and he picked some of these fruits and he put it in the bowl. Now the bowl will contain some of the fruits which were initially in the bucket, like this apple, pineapple, guava. Okay, so now this bowl has the fruits which were contained in the bucket. Alright, so this is the whole idea of a subset. So this whole bucket, it was a set, and the elements of the set. What are the elements? The fruits are the elements of this set. Now, since these elements are taken apart and set put in another bowl, so this bowl will now become the subset of this major set. So this is just for your understanding, and now I'll start defining it mathematically. Now, set A will be is said to be a subset of set B if all the elements of set A are also present in set B. So we can say that set A is contained inside set B. This is basically what we are trying to say. Now, for example, I'll give you an example. Let's say set B will contain A, B, C, D, E. All right. And there is a set A which contains A, C. There is a set C which contains D. There is a set D which contains A, B, C, D. Okay. There is a set E which contains F. Now, is set A subset of set B? Let's check. Element A is there. Element C is also in set B. So set A is a subset of set B. Similarly, set C, since D is in both these sets, so set C is a subset of set B. Similar for set D. Now, is set E the subset of set B? Element is F. Check if there is an element F in this set. No, there is not. So this is not a subset of your set B. So this is basically the concept of subsets. Okay. So basically, the important part of this topic is the important part of this from this topic is proper subsets. So see, subsets can be further classified into two parts. First is proper subset, and the other is improper subsets. Now, this what is a proper subset? So, a proper subset is one that contains a few elements of the original set, whereas an improper subset will contain every element of the original set along with the null set. So, I'll give you an example. Let's say set A includes 2, 4, and 6. Then the number of subsets will be, let's generate the number of subsets. Number of subsets will be, so I'll write down the subsets here. 2 is a subset, 4 is a subset, 6 is a subset. Okay. Then 2, 4 is a subset, 4, 6 is a subset, 2, 6 is a subset. Then 2, 4, 6 is a subset, and 5 or null set is also a subset. अब इसमें से the proper subsets will be how many and the improper subset will be how many according to the definition. So total number of subsets are 1, 2, 3, 4, 5, 6, 7, 8. Number of subsets are 8. Okay. And out of these 8, number of improper subsets. Improper. Only remember the improper subset. That is how you will calculate your proper subsets very easily. So what is the definition for improper subset? Improper subset contains every element of the original set along with the null set. So every element that it must contain is 2, 4, and 6. So this 2, 4, and 6. This is an improper set. Okay, let us write it down over here. So number of improper subsets are 1. Now the remaining subsets, 7 are remaining. 1, 2, 3, 4, 5, 6, 7. 7 are proper subsets. So what is improper subset? Improper subset is a subset of a set which contains all the elements present in the set itself. Alright. Now, there is no particular formula to find these subsets. Now, instead we have to list them all. To differentiate between proper and improper subset, there is only one thing. We can list down all the possible subsets that a set can have, and then we can identify the one which has all the elements which were contained in the original set. This is how we will mark out the improper one, and the remaining will always be proper subsets. So now coming on to the real question, what is a proper subset? So this was a question now. What are proper subsets? Okay. So set A is considered to be a proper subset of set B if set B contains at least one element that is not present in set A. Okay. See, set A, I'll let it down here. Set A is considered to be a proper subset of set B if set B contains at least one. Yani one, it can be one or greater than one. Alright. So set B contains at least one element that is not present. That is not present in set A. Check this. So I'll write set B as A, B, C, D, E. And I write my set A as it can be A, B, C, D, or it can be A, B, C, or it can be only A. So in this case, A, B, C, D, E is missing. So there is a one element E which is present in set B and not present in set A. Therefore, set A is a proper subset. Understood? Like you traverse through the whole set A, okay, and now you traverse through the whole set of B. Now you found an element E which is not present in this set A but is present in set B. So set A will be the proper subset. Again, set A, A, B, C, A, B, C. There are two elements in set B which are not present in set A. Therefore, set A is also proper, and this set is also a proper subset. Okay. Now, how to like in mathematical terms, how do you express this? So, okay, in the condition that we understood in the previous page can be explained as this. So, this is not C. This is like this. Okay, and how does it read? This reads as A is a proper subset of B. Understood? Okay. Now just write down this formula, all right? This will come very handy. And we can define it as proper subset formula. If we have to pick n number of elements from a set which is containing n number of elements, like check this. There's a set which contains n elements, and you want to pick out n elements. So in how many ways can you do this? Number of ways will be number of ways. If you have done permutation and combination, it will be NCN. Alright. Now, therefore, the number of possible subsets containing n number of elements from a set containing capital N number of elements will be equal to this. And how many subset and proper subsets does a set have? So, if a set has n elements, then the number of subset of the given set is like this. If a set has n elements, alright, then the number of subset of the given set is 2 raised to the power of n. And the number of proper subsets, which should be 1 less than the total subsets. Number of proper subsets would be 2n minus 1. Alright. So this ends our discussion on subsets. So let us move on to the next question. Okay. So the next question is rules for determining uncertainty. Rules for determining uncertainty uncertainty in results of arithmetic calculation. On. Now, to calculate the uncertainty, the process that must be used is noted as follows. So, first of all, what you will do, add lowest amount of uncertainty in the original numbers. In the original numbers. Now, for example, if you have to get the uncertainty for 3.2, it will be plus minus 0.1. For 3.22, understood now? The last decimal till you get it, that is the lowest amount of uncertainty that must be added or subtracted in the value. Now we have to calculate these in percentage also. And after the calculation, the uncertainty will get multiplied, divided, added, whatever, and then it will be rounded off. So let me just give you an example for this. Let's say there is a rectangle. There is a rectangle of, let's say, length is how much? 16.2 centimeters. And breadth is 10.1 centimeters. Alright. So now to solve this, you will take length as 16.2 plus minus 0.1 centimeter. And you will take the breadth as 10.1 plus minus 0.1 centimeters. Okay. And now, now you have to convert this into percentage format also. So it will be 16.2 plus minus 0.6 percentage centimeters. And this one will be 10.1 plus minus 1% centimeter. All right. And from here on, if we multiply to get the area is length into breadth, so it will be how much? It will be 163.62 centimeters a square plus minus 1.6 percentage, because these 2% will be added up. See, the errors act in the log format. All right. What will happen is you will do L into B. So if you multiply log A times log B, then you write it as log A plus B. So always make sure that you note that the errors will always be treated as logs. So since you multiplied length into breadth, so zero point 0.6 and 1, these both will be added up together. So the total, the net error that you got in the correction of area was 1.6 percentage. And if we find it out over this original value, 1.6 divided by 100 of this value, it will be 2.6. Yeah. So we can write it as 163.62 centimeters square plus minus 2.6 centimeters square. Okay. Now if we will round it off, we can just approximate this value over to 3 centimeters square. Hence, 3 centimeters square will be the uncertainty or the error in the estimate. All right. Okay. Okay. So next question we have of permutation and combination. So the question states an engineer is required to visit a factory for exactly 4 days. This is where the question will play you. So always note down is have they written exactly 4 days? Have they written at least 4 days? Because if they have written at least 4 days, then what can it be? It can be four and more, like four, five, six. That is also fine. But here they have simply guided us that the engineer should visit exactly 4 days, not three, not five, exactly four. So that is an easy thing. So now an engineer is required to visit a factory for exactly 4 days during the first 15 days. The first 15 days of a month. All right. And it is mandatory that no two visits take place on consecutive days. Then they have given the date that the engineer is trying to visit between 1 to 15th of June of 2021. So this is a simple question. All right. Note this question down, then I'll give you the solution. Okay. So let's say I mark 15 days over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the condition that the engineer should satisfy is that no two visits should come on consecutive days. All right. So what can we do? We have to ignore the 11 days and choose the 4 days. So if uh, we can just cross out the days that we doesn't want to come for it to be non-consecutive. All right. Now what can we do? We have to select 4 days. That means we have to not select how many days? 11 days. So if we are not selecting 11 days, then the number of gaps will be how much? Plus 1. 11 plus 1 is the gaps. 12 gaps are there. Okay. Now in these 12 gaps, we have to fill up the 4 days. So 12C4 will be the answer. That will be equal to 12 into 11 into 10 into 9 upon 3 to 12, 11, 10, 9, 4, 3, 2, 24. 24, 23, 25. 55 times 9. 495 ways are there. So note this down. It is important from this time down. So next question that we have is we have to find the domain and range of the function given as fx is equals to 4 minus x and x minus 4. Now, to get the domain of the function fx, domain for fx. In the numerator part, the x can be anything. X can be from minus infinity to plus infinity. That does not make our function invalid. But in the denominator, we can see that x minus 4 should not be equal to 0. है ना? So this means x should not be equal to 4. So the domain of the function fx must be all real number except 4 or less. And now the range of the function. Range of fx. It will be, if we take minus out, it will be x minus 4. X minus 4 is already there. It is minus 1. So range is only 1. Okay. So the domain of the function is this, and range of the function is this. All right. Okay, so the next question that we have are the real life applications. of limits. Okay, so basically to understand this question, we must understand basically what are the limits. All right, so I'll say that this is a function f and it is dependent upon time. There is anything which is dependent upon time. Let's say it is the population curve. All right, so let's say the population curve is increasing like this, and at some time t, I want you to study the population, the change in population, and the rest of the things. So what you will do? You will just mark a line. You can only tell me the population at this time t. But if I ask you at t plus delta t, the population will change. Okay. So basically, what will happen is if I zoom in over here, if I zoom, it is like this. This was your point of t, and this was your point of t plus dt. So this slope that you are seeing, it is constantly changing. Slope is constantly changing. All right. Now, what's the solution to this? How can you find the rate of change? How can you find anything? If the slope is not constant, then you cannot tell anything about this curve. You can only just pick out the points and tell me the data. All right, but you cannot predict anything further. So what we did was we invented some DC. It is infinitesimally small. Infinitesimally small. Now, what does it mean? It means that it is so small that there is no steep change. If you move along dt along any curve, okay, then there is no major change in the curve. So what will happen is, suppose this is a curve, okay, you are at this point t, and you move dt. So what will happen is, it will be so close to this line that if you zoom it, it will appear to be just a straight line. Not this curved line, just a straight line. And then you can find the slope of this line. And this is how you will tell me about the nature and the predictability of the graph. All right. So this is the basic idea. Now, what are the applications? See, whenever you are driving a car and it is accelerating, all right. See, if a car accelerates from 0 to 60 km per hour in 5 seconds. Now, using limit, you can help yourself and calculate the car speed at precisely any instant. Now, using limits, because it is constantly changing, the speed of the car is constantly changing. So, using limits only, you can find the car's speed precisely at some instant. So, this is what the basic whole idea of this thing. All right. So now we have another question. See, there is a rectangular part. A rectangular part is to be designed whose breadth is 3 meter less than its length. Whose breadth is equals to length minus 3. And this whole thing is in meters. Okay. Now, what else? The area of this rectangular part, इसका जो area है, area of this part is to be 4 square meters more than the area of a park that has already been made. So area is 4 plus a, small a. Alright, and now what is this small a? This small a is equals to area of a park that has already been made in the shape of an isosceles triangle. there is an isosceles triangle. ठीक with its base as the breadth of the rectangular part. So that its base is the breadth of the rectangular part. So it is L minus 3 meters in length. And its altitude is 12 meters. Now we have to find the length and the breadth. So this is the basic question. Understand this question and write it in your own language for you to understand. Okay. So I'll be solving this question now. Now first of all the area. How much will it be? It will be base times height. So it will be how much? 6 times L minus 3. Now putting this A over here, so it will be 4 plus 6 times L minus 3. It will be 4 plus 6L minus 6 is 18. So it will be 6L minus 14 meter squared. This is the area A, capital A. Now capital A is equals to 6L minus 14. And capital A, if I calculate by B into L, it will be L times L minus 3. So it will be L square minus 3L. Now this L square minus 3L will be equal to 6L minus 14. So L square minus 9L plus 14 will be equal to 0. Now L square minus 7L minus 2L plus 14 will be equal to 0. And I can simply say that L is equal to 7 meters. Therefore, breadth is equals to 7 minus 3, 4 meters. All right, simple. Note this question down and note the solution. So I hope that you have noted this down and understood the question. Now moving on to the next question that is based upon the differentiability. Differentiability function. So fx is said to be differentiable at the point x is equal to a if the derivative f dash a exists at every point in its domain given by f dash of a is limit h tends to 0 f a plus h minus f a whole divided by h. Now, for a function to be differentiable at any point x is equals to a, it must be continuous at that particular point. But vice versa is not always true. Therefore, a simple note in addition must be for a function to be differentiable, it must be continuous. It must be continuous. But if a function is continuous at a point, then it does not mean that it will always be differentiable. For a function to be continuous, it is not required for it to be differentiable at that point. Or this. Now let us consider some examples. So let's say fx is equals to 2x minus 3 raised to the power of 1 by 5. Now we have to discuss the continuity and differentiability at x is equals to 3 by 2. Now for checking the continuity, we need to check the left hand and the right hand limits, as we already know. So the left hand limit of this will be limit x tending to 3 by 2 on the minus side, 2x minus 3 raised to the power of 1 by 5. So it will be 2 3 by 2 minus 3 of 1 by 5, which will be 0. Alright, LHL is 0. Now for right hand limit x tends to 3 by 2 from the positive side. So 2x minus 3 raised to the power of 1 by 5, which will also come as 0. So since left hand limit is equals to the right hand limit, so this function is continuous. Continuous where? At x is equals to 3 by 2. Correct. Now, now to check the differentiability at this point, we will write f dash a is limit h tends to 0 f a plus h minus f a whole divided by n h. So limit h tends to 0 f 3 by 2 plus h minus f 3 by 2 whole divided by h. So upon writing it down, h tends to 0. 2 times 3 by 2 plus h minus 3 raised to the power of 1 by 5 minus 2 times 3 by 2 minus 3 raised to the power of 1 by 5 whole divided by h. So now limit h tends to 0. 3 plus 2h minus 3 raised to the power of 1 by 5 minus 0 whole divided by h. So 2h raised to the power of 1 by 5. 2h whole raised to the power of 1 by 5 upon h. So limit h tends to 0. 2 upon 2 raised to 1 by 5 upon h raised to the power of 4 by 5 is infinity. Thus, f is not differentiable at x is equals to 3 by 2. Okay, so moving on to the next question. Now we have to talk about the binomial theorem for any index. Alright. Now binomial theorem for any index, I can write it as 1 plus x raised to the power of n will be 1 plus nx plus n minus 1 by 2 x squared plus n minus 1 n minus 2 upon 3 x cubed. Now, constant term r n minus 1 so on till n minus r plus 1 whole divided by an r raised to the power r. This will be till infinite term. So this is the general term of a binomial equation also. Now we can write the general term t r plus 1 as n minus 1 n minus 2 till n minus r plus 1 whole divided by an r x raised to the power of n. Alright, a plus b raised to the power of n can be written as nc naught a raised to the power of n plus nc1 a raised to the power of n minus 1 times b plus nc2 a raised to the power of n minus 2 plus into b square. So on, so on, so on. And ncr, if I want to write, it will be a n minus r b raised to the power of n r. Alright. Now for n equal to 1 and n equal to 2, we can, this is p n. If you change the n, then we'll be changing of the different things. Now some properties of the binomial expansion. So in the binomial expansion, in the binomial expansion of x plus y to the power of n, the number of coefficients is n plus 1. Similarly, if the coefficient is n plus 1, the terms will be n plus 1. Okay. The first term will be x raised to the power of n, and the last term will be y raised to the power of n. Okay. The coefficients of the binomial expansion can be expressed in the Pascal scale, Pascal's triangle. So the last question for today is how to express irrational numbers on the number line. Alright, so I'll do this with an example. Let's say the question is to represent under root 5 on the number line. Okay, so this is my number line. This is 0, -1, -2, 1, 2, 3. All right. Now, under root 5 can be assumed as the square of 1 square plus 2 square. All right. Now, 1 square. So, 0 say 0 is over here. I'll come up 1. And the perpendicular of the line will be 2. You must be having some doubts by now, but I'll clear them off. First just see. The smaller number that is there will be the distance from the nil point, and the larger number will be the height of the perpendicular. Now, this is under root 5, right? So, if you make this arc on the number line, this point will represent under root 5. Okay, now tell me why have we not done it like this? Suppose this is my 0, this is 1, this is 2. I can just go 2. Okay, 2 is also there now. I can go move forward 2 and then mark 1 over here. And then this will also be under root 5. Okay, and then I'll make an arc. So just tell me one thing. The mark that we'll be getting is over here. So will under root 5 be greater than 2? Never know. Actually, it will always be greater than 2. That is why I wanted to check. Okay. So see where it is coming over here. You move 1 in the forward direction and then mark 2 upwards and then made an arc. So where did this arc come? This arc came between 1 and 2. All right. But where should it come? It should come after crossing point 2. So this is how you will be doing it. So it is a logical thing to do. Okay, no need to like memorize this whole thing. It is just a logical question. If somebody asks you, then you can solve it like this. So that is all for today. This ends our session over here. Thank you for coming.